So thank you for joining us. My name is Alicia Gavin. I am the new digital outreach and design specialist here at RoboNation. So if you're on social media, on our websites, anywhere in that realm, you'll probably catch me. We're so excited to be having Mathworks here tonight, but I'm going to go ahead and turn it over to Janelle Curtis, who is our marketing and strategy director, and she's going to introduce our friends here at Mathworks. Thank you.
Hi, everyone. Thank you, Alicia. We are so excited to have you. Thank you for joining us. Hopefully, this will be very informative and also that you're able to ask questions of the experts. We've got both Shubham and Connell here joining us from Mathworks. They're going to give you the presentation. And then as you can see from the slide, if you're able to see the slide, after their presentation, which will be about 30 minutes, we'll leave plenty of time for questions, especially with these more technical talks. I know that there's a lot of general questions you guys usually have, but also specific. So please don't be shy at the end to speak up, ask the question in the chat, raise your hand, and we will make sure that you get time to do that. That's what they're here for. Of course, the whole point is to get you guys going and doing what you need to be doing with software. So I will hand it over to Shubham, who will be leading today's session.
Hello, everyone. Welcome to this session on working with MATLAB, Simulink, and ROS. So we'll take a quick look at what we'll be seeing today. So here on the right-hand side, I have a Gazebo simulator, okay? And you have a turtle bot which has to follow certain directions and reach the endpoint of a maze. And here we have a algorithm in Simulink that will do that will execute the motions. So we'll take a look at how we can connect MATLAB and Simulink to ROS network and deploy our algorithms for that. So let's take a quick look at agenda today. We'll take a quick look at what MATLAB and Simulink capabilities are for ROS. Then we'll take a look at how we can connect MATLAB and ROS and how we can work with it. Similarly, we'll take a look at how we can connect Simulink and ROS, how we can develop and deploy algorithms in Simulink. Then once you have developed your algorithm and you have tested it, then we'll move on to like ROS node generation, where you can generate a C++ ROS node into your workspace, which can run independent of your MATLAB and Simulink. And finally, we'll take a look at an application example. So ROS supports live network connectivity with, MATLAB and Simulink support live connectivity with ROS and ROS. With live connection from MATLAB and Simulink to existing ROS network, you can explore available topics, services, and actions. Okay. This allows you to send commands and receive data from any simulators, hardware, or software nodes on the ROS network. MATLAB and Simulink also provide utilities to work with common sensor data, such as laser scans, images, and 3D point cloud data. If you're using a recorded data from your ROSBAC file, the toolbox allows you to read this file for post-processing and develop your algorithms. Like once you have developed your algorithm and tested it, you can automatically generate a C++ bit ROS executable. These generated ROS nodes can be integrated with your ROS and ROS2 build system, so they can run on your system without dependencies on MATLAB and Simulink. Okay. Now, on the right-hand side here, you have a traditional ROS-enabled system that might look like. This is a ROS simulator or a hardware. Okay. This is a simulator or hardware that is connected to your ROS, and you communicate it with your nodes to enable autonomy, visualization, and so on. On the left-hand side, you have MATLAB and Simulink. They offer tools for autonomous system development. And an autonomous system must have perception, planning, and decision components to it. And we have a tight ROS bridge from MATLAB to Simulink. So there are basically three workflows. The first workflow is your desktop simulation. This would be a live connection between your ROS and an instance of a MATLAB for algorithm development. The second one is once you have your algorithm developed and tested, you may use the functionality of ROS node generation to generate a C or C++ node that no longer require MATLAB to run. And finally is the data analysis and playback. You log your data from simulation or hardware, then you bring it to MATLAB and Simulink and perform offline design tasks. So now let's take a look at each workflow with some examples. Okay. Yeah. So to connect your MATLAB with ROS, okay, you need two addresses. The first one is your ROS master IP address. So this is the IP address of your ROS enabled system and MATLAB IP address. So this is the IP address of your MATLAB running system. So a machine where your MATLAB is running. Okay. So to get your ROS master IP address, like the ROS system IP address, you go to your ROS machine. Okay. Type ifconfig. Okay. So this address do you see is your ROS machine IP address. Or else if you are using a Mathworks provided VMware, then you have your IP address here. And to get your MATLAB system IP address, in this case, I'm using a Windows machine. Okay, so I'll open command prompt and type ifconfig. So, okay, so here I'm using an Ethernet adapter. Okay, so this is my IP address. Okay, so let's put this here. Okay, then you have to set the environment. So basically what this set environment function does is like it sets your operating system variables. So here our variables are like your ROS master IP and your MATLAB system IP. So yeah. So once the environments are set, you click ROS in it, and MATLAB will connect to your ROS master. Okay. So you can use ROS topic list to know all the topics that are running inside your ROS system. Okay. Similarly, if I want to know a bit about certain topic, then you can use ROS topic info. And here I want to know more about scan. What are the publisher and subscribers to it? So ROS topic info gives me the information of the topic. The publisher here is Gazebo simulator, and currently we don't have subscriber for this. Now, if you want to subscribe to a certain topic, then we use a function called ROS subscriber, and we provide the topic name as an argument. Okay. Then we use a function called receive that will take in the messages. We provide arguments as your subscriber and a timeout. So basically, the receive function doesn't receive the messages within the time step, it gives an error. This thing is basically your design choice. Yeah. So once we have the messages, now we'll read we'll read the messages. Here I'm using read image function and I am show function to display the image to get and display the images. Similarly, you can subscribe and work with your laser scan messages. Now let's take a look at how we can connect your Simulink and MATLAB. So I'll restart my simulator. Yeah. So so now we have our ROS ROS enabled Gazebo environment running. To connect your Simulink to your Gazebo workspace, we go to the simulation tab, prepare, and click ROS network. So here in this host IP name, we provide the IP address of your ROS system. Okay. Then in this node host IP address, we provide the IP address of your MATLAB enabled system. Okay. So with we have successfully connected to a ROS master. Let's hit OK. And on the left hand side, okay, here we have our subscribers. We are subscribing to two topics right now, the image topic and the odometry topic. So what you do is you import a subscriber block from your ROS toolbox. Okay, then open it, select the message you wanna subscribe to. Okay, so in this case, we have already subscribed to the image raw topic, and after this is done, you use an enable subsystem block. Okay, so the reason why we do is because whenever these blocks get a message from your subscriber, it activates and it passes on to your algorithm. And similarly, we do it for the odometry topic. So now we have both the subscriber. Okay, in middle we have our algorithm that will detect the signs, and once we have the outputs, okay, then we need to publish this output. So in this case, in this algorithm, our turtle bot is detecting the signs from this images and calculating the linear and angular velocities accordingly. Okay. So once we have the output velocity, the linear velocity and output velocity, we want to publish it. So here we want to publish it to a command velocity topic. We need 3 blocks to generate a publisher message to publish it. So first one is your blank ROS message. If you type, you can just import it from your ROS toolbox. Okay, and you select the type of message you want to publish. Okay, then you use a bus assignment operator and assign the signals. You connect this blank message and assign the signals that you want to feed it to the publisher block. This you can import your publisher block either by just typing it here or from the library browser. Now, once you have your publisher block, you double click it, select the topic you want to publish, then hit OK. Now, once we have done this, let's run our algorithm. Okay. Yeah. So you can see here that our Turtlebot is taking using its camera to get images, and our algorithm is is extracting the directions from the signs. We're using a state flow chart here, okay? A state machine in state flow, which will basically tell the robot like to turn, stop, or move forward, or scan for the object. And as far as the algorithm goes, we have some scripts that are written in MATLAB, and we have imported them in Simulink. So yeah, if you click at the signals, you can see the values that are going through. So here, if I click at the velocity, it will show me the linear and angular velocity. that's being published. And once the Turtlebot reaches its destination, it stops. So now once you have like developed and tested your algorithm, okay, then we'll take a look at how we can generate a C++ based ROS node that can be deployed to your workspace. So for that, you go to this ROS tab, okay, then select this option, prepare, go to hardware settings. Then you have to select your targeted board as ROS robot operating system. Go to target hardware resources. Okay, you specify your package information. Then this is the device parameter. So basically, we have to provide the IP address of the ROS enabled system, the user ID and the password. You have to provide your ROS folder. Here I'm using ROS melodic. So this is the address to that folder and the workspace which you want to deploy. So here, I don't have any workspace right now. So let's see. Now, when I test this, it's saying me that there is no workspace called catkin ws2. Now you can either you can click on this fix command, and it will automatically generate a new workspace for you. Okay, so now it shows it has successfully created your catkin workspace. Click OK. Then yeah. So there are three ways for the deployment. First is just building the code. So what it will do is like it will just build a C++ code of your model, of your Simulink model, but it will not load into workspace and it won't run it. Okay. Build and run function, it builds your code and it runs your node independent of your MATLAB and Simulink. And build and run functionality, it will build your code. Okay, it won't run it, but it will deploy it to your catkin workspace, the catkin workspace which we saw earlier. So let's go with the build and run and see. So depending upon your system, it may take some time.
So just to give you guys a little bit of an idea as to what's happening right now is the minute he hits build and load, this Simulink is going to call a tool chain that will convert this entire Simulink model into low-level C code that can be deployed. So this is one of the real powerful features of Simulink is that you don't, like I'm a mechanical engineer. I do not know how to write C code. I'm not even going to try to fake it. But I know how to string blocks together because I understand how the schematic of it works. And then you pretty much hit a button and convert everything into your low-level code that's optimized to run quickly. So you don't have MATLAB running in the loop. You're not running an interpreted language. It's more the low-level C code that's going to be deployed into the VMware workspace. And as you can see, it's sort of giving you it's giving you a status update on what's happening. So it's building these different objects and all these different C++ files. The best thing about it is that these files are actually editable. So if you've got strong computer scientists on your team, you as the mechanical engineer or the person that has the domain expertise in, say, perception or planning or controls, can build your code in Simulink and then just hand over a bunch of C or C++ files or whatever other language that you're using, hand it over to your computer programming team and they can integrate that. So the advantages of this is you aren't writing low-level code. You're not writing C code at all. You're working in blocks or a high-level programming language, and and yeah, we guarantee you that whatever code we're generating is going to be bug free, so it'll run.
Yeah.
But yeah, it looks like the model's built. So Shubham, you can keep going.
Okay. So I have to restart the simulator. So I'll again build and run this thing. Now I can see it start. It's building the code. So now when the code is built, okay, it will run the code on this simulator independent of the Simulink. So now you can see the code has been generated, it's been built, and it's so once you finish your code generation part, it gives you a code generation report. You can see here that your uh, node is being generated and it's been executed on your ROS machine. Yeah. So once you have generated the code, it gives you like a summary of all the C++ files that are available. To get to know more about these files, like what these files are and what are the type of macros that are involved in it, take a look at our code generation series. We have covered like in detail about all these files. You can see here that we are the Simulink is not running. It's running independent of the Simulink. Now let's we'll also take a look at how we can deploy this. We can deploy this code into our ROS workspace. Okay. So okay, so it has reached the endpoint and it has. So one more thing, if you're not using a Catkin build chain, if you're using some different type of build tools, okay, you can even change your language to C or C++ here. And if you're using some different build tools, so there are a bunch of build tools that the code generator supports, the code gen supports. Here I'm using my Catkin build tools. So I've selected set the settings to Catkin build tools. Now, if I want to like deploy this code to an hardware, okay, so I click build and load. So what it will do is like it will the workspace which we have created earlier, Catkin workspace 2. Okay, it will deploy this the C code generated from this Simulink algorithm to that workspace, and I'll show you how to manually run that node also. It may take time depending upon the machine you're using. So now it has generated all the C++ files, and it will move on to build process using the it will move on to like building the code. Now it has built the code. Let me restart the simulator. Okay. So let's go to our Catkin workspace. Let's source our environment. Okay. That's it, Catkin main. So now let's go to the lib directory. Now here you can see our nodes being generated into this folder, sign follower robot ROS. Let me restart the simulator. Okay, so once you go to this folder, this folder will have your executable. So just run the executable, and it's running independent of a MATLAB and Simulink. So we run this executable, and the code is being executed in your ROS workspace. It has like nothing to do with your other other MATLAB and Simulink workspace. So let's take a recap of what we have covered so far. Okay, so we looked at how we can connect MATLAB and Simulink with our ROS workspace. So to connect to ROS workspace, you need two IP addresses. One is your ROS master IP addresses. We saw that we can use command ipconfig and get it from your ROS terminals. Then we need your MATLAB machine IP, so we can get that through your command prompt using ipconfig, and you set this environment using set environment variables and hit ROS in it. So that's how your MATLAB connects to your ROS workspace. Then we even took a look at how we can see all the topics that are available using ROS topic list, and how to get information of a specific topic using ROS topic info. Now, let's say you have to connect to ROS2. It's very similar to the process is very similar, like connecting to ROS1. ROS2 doesn't require initialization. So whenever you create a node, ROS2 networks automatically starts. You have to set your ROS domain ID, okay? And as soon as you to start a ROS2 node, you use a function called ROS2 node, specify the name, and start it. As soon as you start the node, your ROS2 network is enabled. You can use commands like ROS2 topic list to get the available topics which you have, and ROS2 node list to get all the nodes that you have. The commands are very much similar to the ROS one, but instead of ROS, you have ROS2 here, and it's similar for Simulink too. So we also take a look at how we can connect to a ROS node. We go into ROS network, specify the Linux machine, the ROS master, the ROS machine IP address, and the MATLAB machine IP address. Then we took a look at how we can create publishers in Simulink. For that, you need 3 blocks: a blank message block, a bus assignment block, and a publish block. So what you do is like modify the bus assignment signal, okay, and feed it to the publisher block. We also took a look at how we can subscribe to the topic. Just import the ROS1 subscriber block from your ROS library and connect it to a enabled system, and connect the new port to enable subsystem. Now, if you want to connect Simulink to ROS2, the procedure is very much similar. Okay, but instead of like the ROS1 blocks, you have ROS2 blocks over here. So this blank message, this is the ROS2 block. Okay, and to publish, you have to get ROS2 publisher blocks. It is similar. You have ROS2 blank message, a bus assignment operator, and a ROS2 publisher block. Then to subscribe, you import ROS2 subscriber block and do the same process. We also took a look at how we can use ROS node generation to generate a standalone C++ code once you have developed and tested your algorithm. Now let's take a look at how we can work with ROS packs. Okay, so let's move on to the software. Okay. Now we will shut down all the. Let's go to the ROS pack folder. Yeah, we have a ROS pack record, ROS back of this environment where Turtlebone navigated from start point to the end point, and we have collected all the ROS pack data. So let's shut down all the nodes that are running. Okay. To import your ROS pack, to see the ROS pack file information, you use a function called ROS pack, and you specify info command and the name of the file. So once you do that, so here we can see all the type of sensor links that are available in the bot and all the types of topics that are there. Now, let's say if you want to get data from certain topics. So here, let's say I want to get image from image topic. Okay, let's say I want to get some images. So I load my ROS back and store it into variable and use a function called find. So what this find function does, it indexes the topic that I'm interested in. So here I'm interested in this topic. Okay, so it will index all those topics. Similarly, it will do it for the scan. So now once you have the index of these topics, you can use read messages function. And here, let's say I want to see the first image. So I select the first index. And it's back over here. So okay. This hasn't done it properly. So depending upon the size of the ROS bag, it may take few minutes. Yeah. So you can use ROS read images to read the image messages, and ROS I am sure to show the images. So here this way I can. Here, so this way I've extracted the images from the ROS packs. Now let's say if you want to get the video feed from your ROS packs. So we use a deployable video player to get that. So here you can see we have retrieved the video feed from the ROS pack. Similarly, you can do the same for your laser scanners if you want to get laser scans. So yeah, so that was how you work with ROS packs in MATLAB. Now let's take a look at some application examples. So on the left hand side, we have a VRX simulator, and on the right hand side, we have a Simulink code. So we are performing a navigation task over here. So this is your code. On the right hand side, you have a Simulink code and we have connected it to our VRX simulator and perform the task. Okay. So we looked at how we can connect a ROS network with MATLAB and Simulink. We also took a look at how we can publish and subscribe to our ROS system using MATLAB and Simulink. And finally, once you have your code ready, how you can generate a C++ based ROS node from Simulink, and how you can manually deploy it to your workspace. We also took took a look at how we can analyze our offline data from ROS bags. Yeah. So if you want to learn about MATLAB and Simulink, we have like excellent on-ramps that will get you started. So MATLAB, Simulink, and stateflow on-ramp will get you started. Like if you want to learn about some new technologies like deep learning, reinforcement learning, machine learning, or signal processing. So we have on-ramp that will get you started over that. And apart from that, we have a student competition tutorial series where you can learn more about aerospace design, race car design, robotics design, and computer vision and code generation. Apart from that, we also have a student blog where we post about the technical success stories that the students have achieved through their projects. To get us software, okay, I have pinned down a link in the here, or else you can go to our page, and in RoboNation competition you can find the link for our software. It's completely free for students participating in RoboNation competitions. And if you have some questions, you can reach out to us on our email, roboticsarena@mathworks.com, or you can post it on our Facebook group. So I conclude this session, and thank you for joining.
Thank you so much, Shubham. And now we're going to actually open it up for questions in the group. So if you have any questions, feel free to put them in the chat, and then we will go ahead and ask Connell and Shubham.
Yes, please don't feel shy to ask questions. I know it's kind of, people get scared, but we're all here to learn. So there are no stupid questions. There might be stupid answers from me, but there are no stupid questions.
And I'm sure the Mathworks team is willing to entertain questions that aren't exactly related to what was presented. Yep. Adjacent is great. I know some of you probably are familiar with or know a lot of what was presented, maybe all of it. And maybe there's other questions you might have. So now is a good time to do that, because of course, other people will learn from it. So please do speak up. Well, I'm just going to fill space until somebody like raises their hand or is brave and puts a question in the chat. But my comment to Alicia was offline was, I feel like we should commission a soundtrack, a RoboNation soundtrack, for when we have these awkward interlude silences while people are gathering up the confidence to ask their question. Or if any of you compose music, I would be happy for you to compose something like that for RoboNation, and we'll give you credit and play it on our community hours. Just throwing it out there. Yeah.
David wants an AI that asks questions. I don't think AI is that advanced yet. It still tells me that my water cup is a cat, so I don't know if it can ask questions.
Does your water cup look like a cat?
This is what my water cup looks like.
Where are you from?
Sorry, can you repeat that?
Where are you from?
Oh, both of us are from India originally, but we live and work in Boston, Massachusetts. So Mathworks, we're based out of this place called Natick. So it's like 30 miles outside of Boston. Yeah, and if you guys are interested in working for the Mathworks, please let us know. We're always hiring. We always have internships available, especially in the summer. If you're looking for you want to come and work for a cool company, please. The weather's actually nice in the summer here. It's not freezing like it is today.
I have okay, Colin, I have one question. Sorry for my English.
No problem. No problem.
Spanish. Okay.
Yeah.
I see in your program the trajectory. When I am student, I use the method of Laplace,
Okay.
the polynomial of third degree.
Yeah.
Okay.
I am a release a trajectory and then plotting in MATLAB, but I never connect them to the Simulink. It's very
Okay.
nice, your project.
Yes, I think it's something that I tell people all the time. The best part about MATLAB is Simulink, and it's a little bit of a shame that they don't teach Simulink as much in university. But once you graduate and once you go to your job, that's everyone's using Simulink there. Most of your most of the cars that you drive are running code that was built in Simulink and then code gen. You know that whole that workflow that Shubham showed where you hit that button and get the C code. Most cars and most airplanes are running code that was built that way. So if you really want if you really want a tool that will help you once you graduate, you should, I'd say, learn Simulink because it's a very powerful tool. And the good thing is Simulink works on, it's sort of built on top of MATLAB, so you can really do a lot of the stuff. You can transfer a lot of stuff that you do in MATLAB directly into Simulink. It either has blocks that are readily available. So for example, Miguel, I know you mentioned like cubic or third order polynomials, curve fittings and things like that. There are blocks available for that in Simulink. So
Nice.
you can
wrote that model?
Sorry, could you repeat?
You wrote that model?
So the model that we showed is actually in the documentation. If you go through the chat, I've popped in a link to that, and you can go check it out. But let me actually look real quick while you're still here for a curve fitting.
So I have other question. Sorry for interrupting. I have other question. If you use what is the name of the simulator of the program? What is the name?
So yeah, go ahead, Shubham.
The Gazebo simulator you're talking about? This yeah, it's the Gazebo simulator.
Okay, and I have the question: why don't use the Simulink 3D animation?
So Simulink. So there are a couple of different reasons. Okay, the reason we use Gazebo here is because we wanted to show you how to connect to ROS, right? Like so for the purpose of this demonstration, we used we use Gazebo. Now there are different reasons as to why you would use Gazebo or Simulink 3D animation. So Simulink 3D animation is extremely good when it comes to modeling physics. Okay, so if you want to model interactions between elements in space and stuff like that, it's very good at that. But it's not so good when it comes to being photorealistic, right? So when you're working with autonomous systems and you have perception systems involved, you want to be able to collect camera information. Gazebo is a lot better with the photorealistic aspect of it, so you can get like camera images that you can use to train networks, or it looks more realistic, look more like real life. But Gazebo does not model the physics of the vehicles well. So in fact, what the typical workflow is, you actually build the simulation environment, or you build the physics model of your robot in Simulink, and then have that basically. So we use this concept called co-simulation. So the Gazebo, for example, so you can use Gazebo or Unreal or any other gaming type of an engine. So Simulink is still computing the dynamics. It's still solving those differential equations, and it's just sort of giving state updates to the simulator. So you can visualize what it looks like in the simulator, but the physics are still being solved and computed in Simulink. I can actually send you a link on co-simulation, which I think will really help you. So the other good thing with and this was added a couple releases ago. So I think it was 2020B. We're on 2022A now. But in 2020B, they added this co-simulation feature, because what would happen is if you'd run a simulation model, Gazebo could update quicker than what Simulink could update. Right, so there'd be like a little bit of a lag, if you will. we've added a new feature now where you can use Simulink to control how the Gazebo simulator updates. So I'll send you a link to it. You can learn more. And if you have questions, we popped in our email address, so roboticsarena@mathworks.com. Just send us an email. We can get on a call and chat about this kind of stuff. Because it may be a little too complicated for a chat like this, but we can definitely have a one-on-one call with you and go through this stuff. I'm just trying to look for the link real quick.
Did you guys just see Bill Van Dalsum used to work with NASA, and he just dropped something in the chat about NASA having used Simulink for the moon mission this flight summer. Just super cool.
Yes, NASA is a big customer.
I sat in many meetings hearing about how good Simulink was.
Okay, I'm just going to ping you guys a link to the co-simulation doc page, and you can see that so it's not just Gazebo that you can connect to. You can we've come. So if I'm not sure if any of y'all are interested in automated driving, but we've just come out with a new tool called Roadrunner Scenario. So Roadrunner, in the automated driving world, they've got to sort of simulate these long what do you say, these long test runs to be able to to prove that the code that they're putting on these automated vehicles are up to code, up to standard. And what they do is they use this Roadrunner Scenario tool to create these various scenarios, like, you've got a vehicle merging onto the highway or merging off the highway or coming to an intersection and all that kind of stuff. And what they do is they create these scenarios in Roadrunner Scenario and export Unreal. So if you're familiar with the Unreal gaming engine, they export Unreal scenes, so they can get photorealistic, camera information, but as well as they also get radar and LiDAR information from there that they can then use in their perception algorithms. But yeah, you can take a look at the co-simulation page. There's a lot of information there on how Simulink controls the time steps and all that kind of fun stuff.
I got a direct message with a question, which was, how do you read an audio file in MATLAB?
We've got a full toolbox for that. Let me, so depending on what kind of audio file, do we have any idea on what the format of the audio file is?
I don't.
Okay. So we've got this function called audio read, which I believe is just in base MATLAB. You don't need any. I'm going to ping a link to that function in there. But this is just a base MATLAB function where you can essentially read an MP3 or a WAV file or what have you. But if you want to do more intense sampling, like I would imagine you're asking this because you want to sample hydrophone data from the competitions that use the hydrophones. We've got this thing called the audio toolbox that you can take a look at, because it'll help you connect to various different kinds of sound cards and stuff like that. So I'm going to also ping you a link to the audio toolbox. The audio toolbox is on the RoboNation license. So you can use that. If you request the software license, you should have access to these tools. Yeah, I just pinged both those links into the chat, so hopefully you can get it from there.
Thank you.
And for everyone that's here, so Shubham, who's on the call, his full-time job is supporting RoboNation competition. So if you guys have questions, if you need help, please reach out to us. We'll answer. We'll get onto phone calls with y'all. We're happy to help in any way possible.
Thank you guys so much. That was amazing. I have no idea what half of it was, but I feel like I learned a lot. This is coming from the non-technical person, or one of the non-technical people on the call. Hopefully the rest of you found it useful. And as both Shubham and Kanal said, They are there to help. Shubham is particularly focused on RoboNation competitions, which is phenomenal. Mathworks has been so incredibly generous with the support that they give to our competition students and teams. So please do make sure you utilize those resources. And if you haven't already requested your free software, please do so. We will be making this recording available, and Connell and Shubham have generously offered to also make the slides available. It may take them some time to get it all the files together and everything, but that ensures that the links that they provided to you in this session are available for you to go back to. And I know that was a lot of information, so hopefully the recording will help as well. And as always, there's a lot of different ways you can get a hold of the RoboNation team if you have questions about competitions. So you've got email that you can get a hold of, autonomy@robonation.org, and the forum, and also to make sure that you register for the next session. Got a couple more minutes if anyone has a last question they've been holding. Sometimes you guys do that. Otherwise, a massive thank you to Connell and Shubham for doing the presentation. Shubham, that was great. A lot of good content there. All right. That's it for this evening, guys. Thank you.
Thank you for joining us, and we hope to see you at our next episode in the series. Have a good evening.
Yep.
Thanks, guys. See you in a month.
Bye.
Peace.
This is the music we need.
No, I feel like we need to commission something specific for these.
Thank you.